Hello. We will be introducing our residential hybrid air conditioning system in this presentation. First, let's take a look at some conventional residential air conditioning systems. The upper left image is the window-installed unitary type air conditioner. It is easy to install and maintain and is also cost efficient as it integrates the cooler and condenser into one unit. On the contrary, it causes heavy noise, has an unattractive appearance and disables the use of windows, and has a lower ADPI with farther distance. It has no ventilation system and each unit can only cover one room. The upper right image shows the advanced split air conditioner which prevent heavy indoor condenser noise. However, these units take over interior space and still leave an unattractive appearance. The biggest disadvantage is that it requires additional refrigerant and drain piping work. This type of AC unit has a low ADPI, requires a separate ventilation system, and each room requires its own air conditioner. On the lower image is the all-air type air conditioning system, which is the refined system of both unitary type and split type AC systems. This system is widely used in North America. It allows one unit to control multiple rooms, allows for silent operation, and has a discrete design. It has a higher ADPI, ensuring better room comfort than the previous units above. In addition to the mentioned advantages, an additional ventilation system is not required. However, it is impossible to operate individually as a room-independent air conditioning system, as while operating all zones are air-conditioned at the same time, therefore causing high electric consumption. Furthermore, outdoor air cooling is impossible due to its insufficient air change rate ventilation. It also causes higher installation costs due to additional ductwork. Now, in order to realize room-independent operation, here's the multi-duct all-air type and all-refrigerant multi-room cooler with a separate ventilation system. First, the left image shows room-independent air conditioning and ventilation operation, which is very easy to maintain and is worry-free of ceiling stains due to its minimal piping. However, image on your right its disadvantages are its high installation costs due to running multiple ducts to each room, and it also requires excessive cooling load due to its common air narrow ceiling space. In addition to installing multiple ducts, this system requires a higher ceiling height and thus increasing construction drawbacks. Furthermore, outdoor air cooling is impossible due to its lower air change rate, and, as a result, an increased outdoor condenser operating time is needed in order to cool indoors even during cooler seasons. The ceiling common return method may result in inefficient air distribution and poor room-independent cooling panels frequently. Additionally, there is an overall difficulty in maintaining the system. Can cause ceiling dust to discharge into the room when the AHU filters are not properly maintained. Now, improving upon all previous systems' disadvantages is our very own hybrid air conditioning system. This system grants much energy saving and ensures best room comfort through adequate ventilation, cooling, heating, independent and selective room control, and VAV control solely with one single air conditioner. The hybrid air conditioning system requires the following factors. 1. Production technology of HVAC equipment and its equipment control instruments which must perform speedy and accurate response to local load variations. 2. Transportation and distribution technology of air conditioning energy must be capable of minutely subdividing air conditioning districts and control technology. 3. Total system control technology must be combined with building enthalpy control using the fused technology of production technology and distribution technology of air conditioning energy. This combined technology will present us with innovative energy saving along with providing the best and most ideal comfort, which could be the most fully realized green technology that the world has desired to date. The main advantages and benefits of the hybrid air conditioning system are 1. Ample energy saving is possible due to exclusive operation in user-selected areas and rooms, along with independent VAV and temperature control in selected areas and rooms. Furthermore, outdoor air cooling is possible. 2. The most ideal room air quality could be kept properly and automatically by a CO2 sensor and also meets the highest degree of LEED by a 7.5 air change rate per hour. 3. A dramatic drop in overall maintenance cost is possible by utilizing unitary air conditioners and our OMNIVENT VAV diffusers. 4. It lowers initial installation cost due to integrated equipment with AHU and condenser which do not require additional refrigerant or drain piping work. 5. The hybrid air conditioning system allows rapid and concentrated removal of heavy dust, odor, and smoke by more than 15 air change rate per hour per room or zone. 6. It maintains rooms at its best comfort, preventing cold drafts due to its air inlet and outlet diffuser locations and VAV control, resulting in even airflow without stagnancy. 7. Solely with one single air conditioning unit, this system will provide the user to select any function such as cooling, heating, concentrated ventilation, sterilization, air purification, humidification, dehumidification, odor control, CO2 control, and also display electric consumption rates and more. The system also provides a perfect solution for buildings with non-opening windows, high-rise apartments with high wind pressure, apartments in areas with poor outdoor environmental conditions such as heavy traffic noise, odor, or dust, which make opening windows problematic, and apartments with room partitions where natural ventilation is obstructive. Such apartments must run conventional air conditioning units for a longer period of time, causing high electricity costs. As shown in the graph, from April to October, there are times in the day when the outdoor temperature becomes lower than the indoor temperature. In these scenarios, with our hybrid air conditioning system, room cooling will be accomplished using outdoor air, which allows the system to only utilize 1/5 of its normal electric consumption. Therefore, during spring, summer, and fall, annual electric consumption could be saved dramatically by outdoor air cooling. Concentrated ventilation is possible by more than 15 air change rate per hour for urgent ventilation for a specific room. Automatic ventilation by CO2 sensor will improve room IAQ with very small air volume. As shown in the middle images, due to supply air returning to the same unit, stagnancy at a room cooler using multiple cooler systems is inevitable at a minimum running stage at small air volume. However, the use of VAV diffusers as a separated inlet and outlet will remove stagnancy and create even air distribution. Therefore, due to prevention of a cold draft, room comfort will be improved by efficient and increased energy distribution. As shown in the lower images, single unitary air conditioners will allow for easier maintenance and lower maintenance costs. Also, equipment installation is trouble-free due to less refrigerant and condensate piping work. As shown in the upper images, significant energy will be saved by being able to operate only in occupied rooms and improve comfort by supplying different amount of air into each room as needed. The middle table shows that room-independent systems save much more energy than house-independent systems. The lower graphs show that the proportional control type with a smaller temperature gap is better than the on-off control with a bigger temperature gap for achieving room comfort. The following diagrams and mechanical layouts show the comparison of our hybrid air conditioning system versus a multi-room cooler with a separate ventilation system. As shown on the following comparison table, our hybrid air conditioning system has considerable advantages on room-independent selective ventilation, selective outdoor air cooling, room-independent VAV control, and room-selected concentrated ventilation. Additionally, there is no worry of ceiling stains from condensation leakage and refrigerant leakage, which results in an annual refill of refrigerant on conventional systems. Also, with our hybrid air conditioning system, a single unitary air conditioner in a mechanical room warrants easy installation and significantly lower installation cost. Therefore, our hybrid air conditioning system is the epitome of practicality and everyday convenience for its users and residents. Hybrid air conditioning system for residential use shall require OMNIVENT's VAV diffusers, AABS, flat ducts, and our very own duct design method. Detailed explanation of each essential item will follow. For VAV diffuser, first, as shown on the upper left images, VAV diffuser must be manufactured to assemble and disassemble its driving parts, such as the diffuser cones and damping bars from the diffuser casings. Second, as shown on the upper right images, diffusers must be manufactured to seal airtight when diffuser is closed. If there should be any air leaks, a whistling noise will be generated to alert the user. Third, as shown on the lower left images, any future wear and tear or defects in driving parts such as diffuser cones or damping bars must be visible at first glance. This will ensure easy maintenance and a longer life cycle of the system. Finally, as shown on the lower right corner, the airflow rate from the diffuser must be linearly controlled with the diffuser's opening rate. Otherwise, a large air volume discharged from a narrow break opening of the diffuser will generate a whistling noise due to fast air velocity. AABS, Automatic Air Balancing System. The conventional diffuser balancing method is to permanently fix the opening rates of each diffuser after each manual adjustment. However, in the room-independent ventilation system, diffuser opening rates are to be adjusted constantly from 0 to 100%. This is called the AABS method and is essential to operation, as the diffuser's driving parts are constantly being adjusted with room occupancy. First, as shown on the AABS schematic structure, AABS is to be installed consisting of the following items: diffuser balancing station, related instruments, computer equipped with AABS program and proper wiring. For back-end or manual TAB work operation using the AABS computer program and or for rehabilitation work, the system is to be sent to the original facility after completion. The standard diffuser opening rate algorithm for all cases of room-independent ventilation at a given specific air change rate shall be accomplished in accordance with the existing manual TAB procedure and is to be saved in the computer. This TAB procedure will be custom-made to fit each individual apartment. Then, the saved standard TAB algorithm will be transferred into the AHU main controller through a laptop computer for all other apartments with the same layout, rather than doing individual manual TAB work. Accordingly, the perfect AABS TAB work has been accomplished for room-independent ventilation system using the OMNIVENT VAV diffuser. Flat duct for air conditioning system. As shown on the images of duct and duct fittings and table, duct height is 100 mm due to narrow ceiling height of most apartments, and the radius of elbows are to be manufactured as long as possible to reduce air friction. Duct design method. To apply the hybrid air conditioning system in apartment complexes, following basic design criteria for duct design should be conformed with the following criteria. First, the apartment ceiling height should be minimum 150 mm and over. Second, the duct air velocity should be 10 m per second and under. Third, main sprinkler pipe should be located at the opposite side of AHU room. Finally, simultaneous operation rate for the air conditioner should be 60% or less. Supply duct and supply diffusers shall be located at exterior zones in order to avoid overlapping with return duct and sprinkler piping, and return duct and return diffusers shall be located at interior zones to avoid any problems, although sprinkler pipings can be overlapped with non-insulated return ducts. Supply ducts must be divided into two different directions, one for left and the other for right, to avoid overlapping with return ducts of the interior zone. Sound-absorbing flexible ducts must be installed between the VAV diffuser and the connecting branch duct to prevent sound from traveling to other rooms and to eliminate AHU fan noise. Main duct height at AHU room and adjacent area must be 150 mm to avoid interruption of ceiling panel installation. From now on, more detailed technical information will be introduced. The following images are various duct layouts of our hybrid air conditioning system. Layouts on the left show a duct design method with supply air through a single duct and corridor space return through a door undercut. The middle layout shows a duct design method with supply air through a single duct and ceiling space return through an induction duct from room ceiling to corridor ceiling. Even though prior two design methods will save initial installation cost, it is not recommended due to inefficient energy consumption and poor room comfort. The duct layout method on the right-hand side shall be mostly preferable for room comfort and energy saving. The following images explain concepts of a few operation modes of our hybrid air conditioning system. Energy recovery ventilation mode runs mainly during the heating period with a small air change recovery with more than 70% energy from the exhausting room air. Bypass ventilation mode runs during spring to fall seasons when outdoor air cooling and emergency ventilation to remove smoke, heavy dust, odor, etc. are needed the most. Fully recirculated heating or cooling mode runs mainly for fast and momentary heating or cooling. Partially ventilating cooling or heating mode runs together with cooling or heating and energy recovery ventilation. The following flow diagrams show split air conditioning systems for cooling and heat pumps, and they can be mainly applied to medium and large-sized buildings. The following flow diagrams show unitary air conditioning systems for cooling and heat pump and can be mainly applied to small-sized buildings like houses and small commercial buildings. The hybrid air conditioning system is divided into two systems. One is the indirect load control method and the other is the direct load control method. The following image shows indirect load control method, which controls total supply air from the AHU by using static pressure variation of the supply duct. The refrigerant or the water flow rate to the AHU heat exchange coil will be adjusted by the difference of desired settings of the static pressure and current pressure. Indirect load control method is recommended for application in large-sized buildings or with buildings with more than 7 rooms or zones. Indirect load control method has a slow air pressure transmission signal speed than the electronic signal, which results in momentary excessive air discharge to the adjacent rooms due to static pressure fluctuation. In addition, air volume control is somewhat difficult because air volume variation is proportional to the square of static pressure variation. On the contrary, it has advantages of easy maintenance and lower initial installation costs than the direct load control method. The following image shows the direct load control method, which controls total supply air from the AHU by summarizing the different pulse values of all supply diffusers in every room. The refrigerant or water flow rate to the AHU heat exchange coil will be adjusted by the summarized pulse value. This direct load control method is recommended for buildings with less than 7 rooms or zones. The direct load control method will prevent sudden excessive air discharge to adjacent rooms because the signal from room controllers will be transmitted to both diffusers to adjust the driving parts and the AHU fans in order to simultaneously adjust the airflow rate. The control differential should be small because air volume variation is in proportion to load variation, and the small control differential with the lower temperature gap will ensure best comfort of the air-conditioned spaces. Thank you very much for watching this presentation of the OMNIVENT hybrid air conditioning system.